Good morning, students. Myself, Sneha, Department of Physics, Kottureshwara College. Today, for BSc 4th Sem, we'll discuss about the Newton's rings. And this will discuss about the how the Newton's rings are formed and how the radius of the Newton's rings will vary. Let us first discuss about the experimental arrangement of the Newton's rings. Experimental arrangements consist of monochromatic source S, convex lens L, two glass plate AB and glass plate G, and one plano-convex lens which is having large radius of curvature and traveling microscope to observe the fringes. Here, Newton's rings are formed when a plano-convex lens is placed on the plane glass plate. When plano-convex lens is placed on the glass plate, then there is a air film is developed in between the plano-convex lens and the glass plate. Here, at the lower surface of the plano-convex lens and the upper surface of the plano-convex lens, there is a thin air film is created. This air film is thickness goes on increases from center of the plano-convex lens to outside. Here the thickness of the air film goes on increases from center of the plano-convex lens to outside. This arrangement is illuminated by a monochromatic source S from the upper side. Let us see how the fringes are formed. Consider a monochromatic source of light is allowed to fall on lens L, lens that is convex lens. From convex lens, light rays becomes parallel and allowed to fall on glass plate AB at an angle 45. When light rays from convex lens incident on glass plate AB, they get reflected towards the plano-convex lens and to the glass plate. When they reflected towards the plano-convex lens and the glass plate, their interference fringes will be appears. This interference fringes will be seen from the traveling microscope. In traveling microscope, we can see these bright and dark fringes. These bright and dark fringes are nothing but Newton's rings. Let us see how these bright and dark fringes will appear. When a ray of light when a ray of light reflected from the glass plate, let us see this diagram. When a ray of light is incident on a plano-convex lens, this is a plano-convex lens and this is a glass plate G. This is the air film between the plano-convex lens and the glass plate. When a ray of light reflected from the glass plate which is incident on the plano-convex lens, it is reflected along one and another. Here some part of the ray is incident on a plano-convex lens at a point D and it is reflected along one, and some part of the incident ray is refracted through plano-convex lens and it is moved towards then it is moved in the air film and it is incident on the plane glass plate and it is reflected along two. Here ray 1 and ray 2 are parallel to each other. These parallel rays will when they superimpose on each other, interference fringes will be formed. These interference fringes are nothing but bright and dark fringes. They are nothing but Newton's rings. If path difference between ray 1 and 2 is equal to 2m plus 1 into lambda by 2, then we'll get a bright fringe. If the path difference between ray 1 and 2 is equal to m into lambda, then we'll get a dark fringe. Let us discuss about that. For the bright fringe, path difference must be equal to 2m plus 1 into lambda divided by 2. As we know that the path difference is equal to 2 mu t cos r is equal to 2m plus 1 lambda divided by 2. Here mu is nothing but a refractive index of the medium. Here we considered the air medium, therefore refractive index of the air medium is equal to 1 and cos r is equal to 1. Here when mu is equal to 1 and cos r is equal to 1, this equation can be written as 2t is equal to 2m plus 1 into lambda divided by 2. Take it as a equation number 1. Here T is nothing but a thickness of the air film, M is nothing but a order of the fringes, and lambda is nothing but a wavelength of the monochromatic light. Let us consider for the dark fringe. If the path difference is equal to m into lambda, then we'll get the dark fringe. Whereas we know that the path difference is equal to 2 mu t cos r is equal to m into lambda. Here mu is nothing but a 1 and cos r is equal to 1. Therefore, this equation can be written as 2t is equal to m lambda, and take it as a equation number 2. Here also m varies from 1, 2 and 3, so on. And let us calculate the radius of the fringes. Here this is nothing but a plano-convex lens. APO is the plano-convex lens and this is the glass plate. Here plano-convex lens is having radius of curvature capital R, and small r is nothing but a radius of the fringes, and T is nothing but a thickness of the film. Here AE is equal to EP and EO is equal to PQ. From the properties of the circle, we can write AE into EP is equal to OE into 2R minus OE. Here R is nothing but a, that is capital R is nothing but a radius of curvature. As we know that AE is equal to EP, that is AE is equal to EP. This is nothing but a radius of the fringes, and OE is equal to PQ, that is OE is equal to PQ is nothing but a thickness of the film. Substitute in the equation number 3, then we will get R square is equal to T into 2R minus 1. Just simplify this, that is R square is equal to 2RT minus t square. Here t square is very small, therefore we neglect the t square value. Then we can write r square is equal to 2rt. From this we can write t is equal to r square divided by 2r. Here small r is nothing but a radius of the fringes and capital R is nothing but a radius of curvature of the plano-convex lens. For bright fringe, we got from equation 1, that is 2t is equal to 2m plus 1 lambda by 2, where we got the value of the t, that is t is equal to r square divided by 2r. Substitute that in the above equation, then we will get 2 into r square divided by 2 into capital R is equal to 2m plus 1 into lambda divided by 2. Here 2 get cancelled, then we will get r square divided by capital R is equal to 2m plus 1 into lambda divided by 2. Therefore, we can write small r square is equal to 2m plus 1 into capital R into lambda divided by 2. Then we can write radius of the fringe, that is r is equal to square root of 2m plus 1 into r into lambda divided by 2. If we write for the nth fringes, then Rn is equal to square root of 2m plus 1 r into lambda divided by 2. Here Rn is nothing but a radius of the fringes. This Rn is directly proportional to square root of the 2m plus 1, and Rn is directly proportional to square root of r, and Rn is directly proportional to square root of lambda, that is radius of the fringes is directly proportional to 2m plus 1 and radius of the fringes is directly proportional to square root of the radius of curvature of the plano-convex lens, and radius of the fringes is directly proportional to square root of the wavelength of the monochromatic light. If we got the radius of the fringes, then we can calculate the diameter of the fringe. As we know that diameter is equal to 2 into radius, that is d is equal to 2 into r. Therefore, d can be written as 2 into square root of 2m plus 1 r into lambda divided by 2. Now we'll see for the dark fringes. As we know that for the dark fringes, 2t is equal to m lambda. A t is nothing but the thickness of the film, where we got t is equal to r square divided by 2r. Substitute in the above equation, then we'll get 2 into r square divided by 2r is equal to m into lambda. Here 2 to get cancelled, then r square divided by capital R is equal to m into lambda. Then we can write r square is equal to m into lambda into r. Then r can be written as square root of m into lambda into r. For nth fringes, we can write Rn is equal to square root of m into lambda into r. Here also radius of the fringes is directly proportional to square of the m and square root of the m, and radius of the fringes is directly proportional to square root of the wavelength, and radius of the fringe is directly proportional to square root of the radius of curvature of the plano convex lens. If we got the radius, then we can calculate the diameter of the dark fringe, that is diameter is equal to 2 into radius. Therefore diameter is equal to, that is diameter d is equal to 2 into square root of m into lambda into r. In this class we studied the how the Newton's rings are formed and the radius of the Newton's rings. Thank you.